everyone, and welcome to your Engineering Tomorrow app development introduction. My name is Lauren Sawyer, and a little background about me. I graduated from Penn State University with a degree in aerospace engineering and a minor in marine science. That kind of sounds like an odd combination, but it helps me today. I am a master's student at the University of California, San Diego, and I do a lot of research with the Scripps Institute of Oceanography Marine Physical Laboratory. I focus on autonomous vehicles, how they move around underwater, and how we can locate them in real time underwater using acoustic transponders and an algorithm that runs on board the autonomous vehicles. With that, let's jump into your app development breakout team. So these are the people who were really helpful in developing this lab over the summer. And we've got two college mentors, Bella Matuch and Emily Millian. I had the pleasure of working with them this past summer, and they've created an awesome lab for you guys. Part 1, Introduction to App Development. So first, we want to go over what is an app. The most popular app of all time is actually Facebook. It's the most downloaded app in the last decade, but TikTok is very quickly becoming the most downloaded app recently, and it might even surpass Facebook in a few years. The average person uses 9 mobile apps per day, and that might not sound like a lot to us, but this is factoring in everyone in all generations. And the average person also uses about 30 different apps per month. 175 billion apps are downloaded annually, and there are 2.87 million apps available to download from the Google Play Store or the App Store for iOS. Android and iOS app revenue reached 133 billion in 2021. Games, entertainment, and social media are definitely popular uses of apps, but a lot of users rely on apps to increase productivity, manage their business, read books, plan travel, keep up with the news, increase their knowledge, and improve their health and fitness. Apps have become, in a sense, a way of our modern life. So this week, we are going to be designing a mobile app using the MIT App Inventor software. Let's first watch this short video to learn a bit about the history of apps.
In the beginning, apps were just simple little things, no network needed. Just fun or basic utility apps. Then we started getting social media apps to stay connected with our friends all the time. Facebook, Twitter, Snapchat are all complex apps with communication ability, databases, networks, and even geolocation based. While these apps were fun, they weren't entirely useful for business. Then along came shopping apps like Amazon and eBay. These apps allowed you to order stuff when you're thinking about it, instead of waiting until you're in front of a computer. Very convenient. Then along came service provider apps like Angie's List that let you connect with a service provider like a roofer or door repair or handyman. But these services weren't real time. They could often take days to make an appointment. Then along came Uber, and it just blew up everything in its path. It has GPS, real-time communications, high availability, always available, redundant databases, geographically dispersed, and load shared for extreme reliability. If one cluster of systems is unavailable, all other clusters take over. Instant real-time dispatch of the service, private. Database of driver information. Database of passenger information, including payment. Instant payment from passenger to driver while sharing of commissions with Uber. Instant qualifications of the fare with instant calculations of distance and time.
So here's the brief timeline that was mentioned a little bit in that short video. It provides some key milestones in app development. You can see some events happening in the 20th century. IBM smartphone preloaded with apps like the address book and the calculator. Some Blackberries, I remember in the early 2000s, were downloaded with the snake game where you had to eat the little cubes without eating your tail. I definitely played with that a lot in my childhood. That started in 1997 with the Nokia mobile phone. So in 2007, the first iPhone was released, and just a year later, the Apple App Store was launched. And that had a capacity for a lot of different apps to be downloaded, for you to customize what kind of apps you wanted on your phone. In 2009, some of you may remember, Angry Birds was released. It was one of the highest played games in the nation and potentially worldwide. In 2010, app was voted word of the year. And the phrase, let's make an app out of that, or can you make an app out of that, was definitely widely thrown around in the modern lexicon. In 2011, Uber was launched, and this was one of the first apps that you actually got to interact with and had a result happen in the real world, such as a car would come to your location and someone could drive you. So this was kind of the advent of the whole rideshare technology, and it was a big stepping stone for apps in general. So now we have to talk about what do you need to design an app? And the first thing you might think about is solving a problem that you experience in daily life. And this often starts with the customer, who they are, what their needs are, and what their wants are. And this should be expressed in the customer's own words. Sometimes you hear this referred to as getting the voice of the customer. And you may think that this is an obvious place to start, but the term voice of the customer wasn't actually coined until 1993, when all of this app development technology began. Before that time, engineers designing the product would often assume that they knew what the customer wanted and prematurely create a design that they would then give to the customer at the end of the design process. And the customer would not always respond well because they weren't consulted during this process. So today, you may also hear the term human-centered design. And in your student interactive workbook, we discuss the engineer's need to have empathy and a relationship with their customer when designing solutions. After you understand what the baseline problem is that you're trying to solve, you can brainstorm ideas and solutions that will address the problem. You can often find inspiration from previous solutions or previous work that other people have done that you can then build upon. To make this idea a reality, you need to know how the technology works, and you need to know how it's going to persevere into the future. This takes talent and perseverance, as you are not always successful with your first design. In fact, you are rarely successful with your first design. And improving on a product means that you have a first working design, give it to the customer, they'll give it back, they'll give you a list of things that they want changed or improved upon, things that they want you to add, and this will help create a very useful and thorough app. All of these components, understanding your customer's needs, coming up with creative solutions, and implementing them successfully are required to finally launch your successful app. So now we're going to talk about front end and back end design. And the front end is exactly what the user sees. So on a website, this will be what you see when you open google.com or engineeringtomorrow.org. And this entails the graphic designer and user interface components of an application. Everything the user sees and interacts with when they open an app is this front end design. Conversely, you have the back end design, and this is what the creator of the app or the website is going to directly interact with when they're making changes with that website. Think of the back end as the invisible structure that helps the app function properly. You guys are going to do this in your student interactive notebook. You're going to click this link to access Engineering Tomorrow's website in a Chrome browser. And this is important because every browser will show you different inspection tools. So in order for this to run smoothly, make sure you guys are using Chrome. And so you're going to right click the view page source, which is outlined right here. And then you guys are going to look at the different lines of code, and any changes that you make will reflect how you see the website on your own computer, but won't change the source code or the code that helps the website run as a whole for everyone who views it. So you guys are going to actually find this particular line of code, and you guys are going to answer in your student workbook after you click inspect. And notice the event listeners tab, and based on observations, you're going to answer for yourself what you think an event listener is. This will all be outlined in your student interactive notebook, and you guys can follow the steps that are seen there. So now we're going to get into app terminology. There are a few different terms that you need to be comfortable and familiar with in order to design your apps for this lab. So first, we've got visible components, and these are text boxes, buttons, things that the user will physically interact with when they are on the website. This is part of front-end design, something that the user sees. Non-visible components are sound, accelerometer, orientation, sensors, all components which are not seen but provide built-in access functions to the website or device. This is the back-end design because the user isn't directly interacting with it, but it creates a good experience for the user. So for property, each component is characterized by various properties, and the state of each component, visible or non-visible, is determined by the property. For example, the state of a label could be the text "Hello World," which is a common coding phrase that we use to make sure a code is in fact working. A variable is a storage container for information. So if you think of algebra, 2x equals 8, that variable x stores the information that it's equal to 4. This information could be a quantity, a letter, or a word, and it's just storing an array of information that your website or code will access. Next, we go into a Boolean, which is a specific type of variable that is either true or false. So this won't have numeric quantities like x is equal to 5, 7, 9, etc., but it will only be equal to 1 or 0, with 1 equal to true and 0 equal to false. So if you give the code a statement and then you can determine whether it's a Boolean variable, your code can actually determine whether that statement is true or false by outputting a 1 or a 0. An event handler dictates the action that follows the event. A programmer writes code for a specific action to take place when some event occurs. You can see this on different websites, such as when you click a link, it'll take you to that new link's specific address. That would be an event handler. So we're going to watch this video on conditional statements, and you guys are going to determine what this specific conditional statement would print.
Our daily lives are filled with decisions, big and small. Even simple choices like what to wear usually are the result of complex considerations. What's the weather going to be like? What will you be doing today? Do you feel like making an impression or keeping it casual? But the world around us is constantly changing, so we want to adapt the choices we make to match the changing conditions. What's true for humans is also true for computer programs. We don't want our programs to always run in the same way. They should respond to changing conditions. In the last video, we learned how to use Boolean expressions to establish whether something is true or false. We can now add something called a conditional statement to help guide the computer's decisions based on that information. The simplest conditional statement is an if statement. It says that if something is true, the computer should run a specific block of code. Let's say that you want to create a program that displays whether or not you are old enough to see a PG-13 movie. So the question we want the computer to evaluate is, if age is greater than or equal to 13. The question, or Boolean expression, goes next to the if. The block of code we want to run, only if the condition is true, goes inside the if statement. So in our example, whenever the expression age greater than or equal to 13 is true, the program will write to the screen that you are old enough to see a PG-13 movie. Of course, some people will not be old enough. In these kinds of situations, we will want our programs to do something else when the condition is false. In order to do this, we will want to expand our if statements to include an else statement. The commands contained in this else statement only run if the Boolean condition in the if statement is false. You can add an else statement by either dragging out the if-else block or by clicking the plus symbol in the bottom right corner of the if block.
Now that you guys have watched the video, think about as a class what this if statement will produce when dogs is equal to 6. So when dogs is equal to 6, this will enact the first statement for when dogs is exactly equal to 6, which we see that this variable is. This will print, wow, you have a lot of dogs. And that's what will happen in this coding segment. If you want additional information about conditionals, we've got a bunch of different resources that are linked in your student interactive workbooks, and you can find them when you start the lab. We're going to watch this video and just give you guys a little bit more familiarity with conditionals and the language of code.
Sometimes the decisions you will want your program to make have more than 2 possible outcomes. Let's continue our movie rating example, where we want to check whether the highest rating you can go see alone is an R-rated movie, a PG-13 movie, or just a G-rated movie. To check between these 3 different cases, we can add an else if statement. An else if statement is another condition that a program checks only if the previous if statements were false. So if age is greater than or equal to 17, write that user can see an R-rated movie alone. Else if the age is greater than or equal to 13, write that the user can see a PG-13 movie alone. Else, write that the user can see a G-rated movie alone. The else condition becomes the default condition, because when all the previous if and else if statements are false, it will default to the else statement. Be careful as you construct longer sequences of else if statements. If you mix up the order, you might not get the behavior you intended. In our example, imagine we had switched the code so that the first condition checked if the user was old enough to see PG-13 movies, like this. This would mean that everyone who is 13 or older would be told they can only see PG-13 movies, even the adults. And with the next else if line, the computer would be looking for people 17 or older in the remaining group. This code misses the adults because they were true in that first condition. This won't work. The computer checks the conditions from top to bottom, so it is important to enter the most specific condition first.
So now we're going to talk about different kinds of programming languages. There are about 700 different programming languages, or different ways that we can talk directly with a computer. These listed are some of the most popular ones for coding apps. For example, in my research, I use a programming language called MATLAB, which is Matrix Laboratory. That's what it's short for. And it allows me to do a bunch of different mathematic operations run by the computer, and even solve things that we don't specifically get answers for when we solve by hand. It's a very powerful tool to simplify my life by allowing me to not do such complicated mathematics by hand, and give me a worthwhile and trusty resource for mathematical operations that I might not necessarily be able to compute within a few hours. It can do them within a couple minutes. So what's the purpose of having so many different programming languages? Each language offers its own unique benefits, such as C++ was created out of a desire to make C a little less complicated. Many say that building a program in C is like building a car from scratch, and C++ has those preloaded libraries that allow you to use work that maybe other people have started that you can then build upon. In the end, choosing what language you use depends on what kind of platform you're building. Python is often favored because of its simplicity. It's known as a high-level programming language, which means it's easier for humans to communicate with it, but it takes a little bit of work on the computer side to understand what we're talking about. And we'll talk about this more in the next slide. So you guys are going to be using a program called Scratch, which is a high-level programming language that's often used for beginners to learn how to code and to learn how to communicate with the computer. This is aimed to help students learn the fundamentals of coding. It implements visual blocks instead of typing commands into the computer. And these blocks you guys can move around if you accidentally put your conditional statement before something that you wanted to happen at the very top of the code. If you're unfamiliar with Scratch, there's a tutorial in the Student Interactive Notebook that can help you get familiarized with it. So here's that tutorial. You guys can watch it if you need to. It explains how to make a bird fly using Scratch, and we will play it here just for you guys to get a sense of what we can do in Scratch.
Hello everyone, it's Becky from Pingua. Welcome to episode 5 in our Scratch Basics series. This episode will take you through the steps of making your sprite fly around the stage. First, you'll want to start your project by adding a sprite and a backdrop. For help on this step, watch episode 2 in our Scratch Basics series. Once you've added your sprite, make sure you've clicked on it in the Sprites pane here. Now it's ready to receive code. We're going to start by adding an events block, which will tell our code when to run. Click on Events in the block palette, and then drag a When Space Key Pressed block. This is a keyboard input block, which means that when we press the space key on the keyboard, whatever code we add underneath will run. If you click the drop-down menu here, you'll access all of the different keyboard input options you can choose from. You can choose arrow keys to start your code. You can choose letters on your keyboard to start your code, or you can choose numbers to start your code. I'm going to stick with the space key. Next, go to the motion category here. These blocks control the movement of your sprite. Grab a Glide 1 second to random position block and snap it right underneath your event block in the code area. This motion block will have your sprite glide at a steady pace to a random position on the stage for 1 second. Let's test this out. When I click the space key on my keyboard, my sprite glides to a random position for 1 second. If I hold my finger down on the space key, my parrot sprite continuously moves to random positions for 1 second. And he won't stop until I take my finger off the keyboard. The first white bubble in this motion block is a number input. This is where you can change the number of seconds that you want your sprite to glide for. If you make this number larger, like 8 seconds, for example, our sprite will move much more slowly. This is because it's taking 8 seconds to glide to that random position. Now if I change this number to a smaller number, like 0.2 for example, and press the space key, you'll see that the sprite moves much more quickly because it's gliding for less seconds.
So today's challenge is you're going to code a text-to-speech app in MIT App Inventor that's creating your own deep fake. We will further explore the topic of deep fakes throughout the workbook, but let's get started. Once you're comfortable with Scratch, you guys are going to be able to move on to this MIT App Inventor. So we have to talk about what is a deep fake. And these are video and audio files that are made using artificial intelligence. Powerful computers make deepfakes by learning from existing records of humans. And the term deepfake comes from deep learning. Deepfakes, when thought to be real, can very easily spread misinformation and use others' fame to promote messages. These messages can be funny, political, serious, and you might have seen a lot of them in recent years. So you guys are now going to watch an example of a deepfake. While you're watching this video, I want you all to keep in mind that this is not Morgan Freeman. This is not a video he's ever recorded, but it's in fact artificial intelligence that uses the sound of his voice to articulate different words that he's never actually said.
I am not Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality. Now, what do you see?
So now we're going to talk about the engineering design process. And this is what you guys are going to use while you're developing your app. Very similar to the app development process where you communicate with the client repeatedly throughout the process. You guys are going to think about how the engineering design process is going to apply to your app development process. So now getting started with the App Inventor, you guys are going to go to the website appinventor.mit.edu, and there's a convenient link in your student interactive workbook with all of these instructions repeated in your workbooks. You're going to click the Create App button, and then you're going to sign in using your email account. This will create a free account. When you're finished, you'll land on the projects page. A pop-up saying get started with some tutorials appears. You're going to have to click close on that so we can learn how to navigate the App Inventor ourselves. Before you build your app, here's something that you guys should keep in mind. Make sure to download this app to your phone and read the instructions. The cool thing about MIT App Inventor is it lets you see how the app would look on your phone in real time, but only if your computer and phone are connected to the same Wi-Fi network. And you have to have this app downloaded. Additionally, if you do not have a phone available for use, complete the app tutorial independently and then share a phone with a friend so that you can see what your app would look like for a phone's user. If you're interested in today's breakout, you may be interested in topics such as programming, digital design, artificial intelligence, app development, and human-centric design. The specific types of engineering relevant to today's MIT App Inventor breakout include computer science, software engineering, computer engineering, and electrical engineering. These are the types of engineering that you might study in college or major in college if you really want to become an app developer or app designer. Thank you so much for joining us with your app development introduction at Engineering Tomorrow. If you have any questions or concerns, please email your coordinator at Engineering Tomorrow, and we will see you soon for your College Mentor Q&A session, where you can ask the College Mentors any questions you have about developing your app, any hiccups you ran into in the process, and you can even ask them any questions about what it's like to study engineering in college. Thank you all and have a great day. Welcome back, everyone. My name is Lauren again, and I am going to walk you through the app development extension activities. So you guys should have finished up your app development lab, and hopefully you guys designed some really great apps, and we're excited to see them. But here are a couple things that you guys can add to your apps so that they look more like what the apps you see on the App Store might look or Google Play might look like, and they make them really user-friendly. So these are some challenges for you guys to embark on. So the 4 challenges that you guys are going to see are showing numerical values in your apps, adding accents, male and female voices, and then just the general visual appeal, what the user sees, how to make it easier for the user. So we're going to walk through all 4 of these activities, and you guys are going to try your hand at them. The first one is adding numerical values. Think about how much easier it is to control values such as volume when you can see the numerical value. Instead of just having a slider, you can say, okay, from a scale of 0 to 100, I want my volume to be at 70%. Maybe that's too loud. You drop it down to 50%. It's a lot easier for the user to control what they want out of the app. So you can make your app better equipped for precise control by adding values for the pitch and rate sliders. You guys can add your images to the Student Interactive Workbook here of your sliders, and we would love to see the results of this. The next step is adding accents. And this is kind of making your app more complex, and it's also making it, a little more worldwide friendly. People have different accents. There are different accents when we speak different languages. such as Spanish. And so you can add these accents so that the pronunciation sounds right. You can type or paste into the app text in another language. For example, if you know Spanish, if you know French, maybe even Mandarin, whatever language is easiest for you. And then you can figure out how to set text to speech to read back the text in an accent that's more natural to that language that you're now using. So you can set text to speech one.language block and the language code ES, which is Espanol, to get a better Spanish accent. And then there are other shortened language codes for other different languages. French would probably be FR. You can scroll through them and see which one you're translating for your own language. Again, we would love for you to answer this question here. Just how can you allow the user to insert their different accents? We'd love to see your results in the Student Interactive Workbook. Now we're going to focus on male and female voices. So obviously there are different types of genders all around, and we want the user to have an experience with their app that maybe reflects them and their whatever they're comfortable with listening to. So you can play around with the different voices, and you've probably heard this in a lot of GPS and navigation apps. You can make it British, you can make it male, you can make it female, you can sometimes even make it the voice of a famous person whom they ask to record different slogans. So you guys can play around with all of the different voices in your app. And in iOS, you're going to look in the settings for voiceover under accessibility. And then in Android, you're going to look for text-to-speech output in the settings. It's kind of different just because of the compatibilities with Android and iOS, but play around with these features, see if you can change the type of voice that's reading out all your text. And then we'd love for you to tell us what kind of changes in the voice you made and what voices were your favorite, what voices actually dictated the best. So that means like which can you hear the distinct words from the better than others. Maybe one accent is better than another accent to really get all the words that are being read off of your app. And then finally, we're going to go into visual appeal. So this is just all of the fun graphic design touches on your app. This really makes it easy for the user to see exactly what they want to see at any given point in time. I've definitely used a lot of apps where what I'm trying to find is really, really hard. And I have, a ton of ideas for, well, maybe they could put this toggle switch, on the main screen so that I don't have to search for it in order to turn up or down the volume. And this is where you really have to think about what the user wants and what the user is going to be using your app for. And you want to put all of those main functionalities front and center for them. So you can spend a few minutes making your app look more professional and more appealing for the user. And this isn't just putting all the different functionalities on the main screen. This is adding color, adding pictures, playing around with the actual design. People love something that looks well designed and is meant to be there. So you can play with different fonts, colors, components, really make this app scream you. People love to see you on the screen. So we want to see your unique apps, and we would love to see how your final version of your app turned out. So please add your image to the Student Interactive Workbook when you're done designing your app. Thank you all, and we hope that you embark on this extension activity, and we can't wait to see your results.